So this was a feature that when I first saw it, I was like, whoa, brain explosion. And that was the feature of rooting instances. And this is where you could divide the Junos appliance logically into effectively multiple devices. So each device will have its own separate routing table, its own interfaces, and its own routing protocol. And the following are some of the common routing instance types. So you could have like the routing instance of forwarding, used to implement filter-based forwarding, and then you could have like, and that's for common access layer applications. Then you could have an L2 VPN used in layer 2 VPNs. No forwarding used to separate large networks into smaller, manageable, bite-sized chunks. And then you could have the virtual router used for non-VPN related applications, such as system virtualization. That's probably what we're going to use in this example. Then you have VPLS used for point-to-multipoint LAN implementations between a set of sites in a VPN. And I'm also going to mention the VRF, which is used in layer 3 VPN implementations. So let's have a look at our lab again. And here you can see what I'm actually trying to implement. You have router A, B, C, and D. Now router A will have the IP address of 200.1.1.1, but router B will also have the same IP address of 200.1.1.1. Whereas router C will have the IP address of 200.1.4.1 and router D will have the same IP address. And routing instances makes this possible because as it separates the routing tables, then each device can have it duplicate IP addressing basically. But rather than just talking, let's jump onto the switch or the MX routing device, and have a look at that. Now, if I say edit, and I should have just done it from here, run show interfaces terse, and we've still got that IP addressing that we had previously. And I did mention the rollback command, but we're going to implement it here. Now, if I say run show system commit, I'm doing this on the 5th of December. I'm looking at probably this one. So if I was to say rollback 13, it will roll back to what is under this number 13. But to verify that further, if I say exit, then I say show system rollback, and we compare what's in my current rollback to what's in 13. So we're going to add these two IP addresses, and we're going to take away all of these IP addresses, which looks good to me. So if I say edit now, rollback 13 and commit, run show interfaces terse, and we can see that all of that IP configuration has been removed, apart from this, which was obviously there in our rollback 13. So we're going to delete that as well, and then we're going to do some configuration. Now I've already done the configuration on the host devices, so I should only need to do it here. So edit interfaces, edit GE000.0, and then I could delete the family inet. Commit check that. Good. And also we're going to do a show compare just to see what it will take away. Yeah, let's commit that. Alright, now let's do the configuration. So the first one was GE000, but I'm going to have to do this configuration under the routing instance. So if I say here top, and I will say something like edit routing instance, I'm going to give it a name. Let me just say test instance A, and then I will say we're going to set the instance type to virtual router, and we're going to add the interfaces that are going to be under test instance A. And the first one is going to be set interface GE000.0, and also I think it was, and also I will do a static route to their loopbacks, and I will do that under the routing options underneath the virtual instance. So set routing options and a static route to get to the 143.0.0.1/32 network. Our next hop under this routing instance is going to be 200.1.1.1. Okay, that looks good. And let's do the same for .3, and we know that's going to be 4.1. and that is also 143.0.0. I think that's it. Let's do a commit check. Looks good. Before I go back, let me just say up, and we're going to create another routing instance for test instance B. So set test instance. I wonder if I could tab that and just change it here. Set test instance B. And do the same again. So set interfaces. Under this is going to be GE001.0 and 2.0. And we're going to set their static roots as well. And I should have probably done the IP addressing first, but let's see if this works. So set routing options, static root, to get to 143.0.0.1/32. Our next hop will be 200.1.1.1. All right, let's commit that. Guys, I have a request from you. If you're enjoying the free content, I'm looking to increase my subscriber count to 4,000 subscribers by June. But I can only do that if you give me the play special. Do you want to know what the play special is? Press like and yeah, subscribe. Okay, back to the video. And then I should just have to configure the interfaces normally because they're already being committed to that routing instance. So if I say edit interface GE000.0, family INET address of 200.1.1.1/24, set GE003.0, family INET address of 200.1.4.1/24. Now .2 will have the same IP address, and usually the router would complain, but let's see if it allows me. So make this the same and make this 1.1 under interface 1. Commit check. It allows it. Let's commit that. Now to ping this interface, we have to ping it under the actual routing instance, but we could also do run show root for the table, and it's test instance A dot inet0. We can see it's segregated that routing table. So these are the only routes that we see in test instance A routing table. And we could do the same command for test instance B. Now let's just see if I can actually ping the loopbacks. So if I say run ping 143.0.0.1, which is in routing instance, test instance A. And there's no route to the host, so I've done something wrong there. Let's see if I could actually just ping the normal interface without the loopback in test instance A. Then I will have a look to see what I've actually done. So run ping 200.1.1.1 under the routing instance, test instance A. I'm able to ping that. It's probably because that loopback isn't under that routing instance. Invalid routing instance, test instance B. Okay, so I didn't set the instance type under test instance B, so that's why that says it's an invalid routing instance. So let's do that now. Edit routing instance, test instance B, set instance type to virtual router. Let's commit that. Yeah, and we could ping it. Now let's see why I wasn't able to actually ping 143.0.0.1. Run show root for the root. Run show root for the table, which is test instance A inet.0. Run show routing instance. Not run, sorry. Show routing instances. For the static root 143.0.0.1, the next hop should be 200.1.1.1. Okay, so I see why it wouldn't work here, but it should work here. This, because the root is incorrect, but this one, the root is correct. So if I say now run ping routing instance, test instance A 143.0.0.1, and it says no root to the host. Can I ping it directly? Ping 143.0.0.1. Yes. Ping 200.1.1.2. Alright. So maybe my IP addressing is wrong. So let me go back onto my VCP and I'll say run show interface terse. That's why, because I put the wrong IP address here. So what I could do, I have to change these to 200.1.1.2, not 200.1.1.1. So I will do that now. Edit interface GE000.0 family INET address of 200.1.1.2/24. Commit. Still no root to the host. So I'm actually thinking, what's going on here? Let's do a bit more troubleshooting. Why can I not ping that? And I'm thinking, the first thing I would do is look at, can R1 ping our router? So ping 200.1.1.2. Oh, R1 can't even ping the router, so that makes me think on the router there's an issue. If I do a run show interface terse, there we go. So I did replace it with the correct IP address, but I didn't remove the other address. And on Juniper that you could put, that you could put many IP addresses under the same unit. So I need to get rid of the 200.1.1.1. So let me go edit interfaces GE00.0 family INET and say delete address 200.1.1.1/24. Let me commit that. That should have resolved the issue. Now if I go to the top of the hierarchy and say run ping 143.0.0.1 for the routing instance of test instance, and there we go. Oh, alright. So thank you for watching that one, and you know what time it is now? It is question time. Question 1. Which routing instance is used for non-VPN related applications such as system virtualization? Question 2. Which routing table will contain the routes for the routing instance called test instance A? Question 3. Which routing table, by default, deals with the IP version 4 unicast routing? Question 4. Which command allows you to see the summarized state of your interfaces? Question 5. What are some of the advantages of using a routing instance? Choose 2. Question 6. View the exhibit below. You are sure that your colleague has set up the static root in test instance A. What can the problem be?